I'll just start once again. Very good evening, good afternoon, good morning, everyone who is joined. Thanks for your time for this demo session. So today we are planned for a live demo for Pinakastra Cloud, and when I say a live demo, so there is a disclaimer. As everyone knows, when there is a live demo, chances are there for few technical glitches, so taking an advance disclaimer for it. So anyways, let me start by having a quick introduction. I'll share my screen. Please let me know when you are able to see my screen. Hope my screen is visible.
Yes, sir.
Anybody not able to see my screen? Okay, great, fine. So let me continue. So, as planned, today we are going to have a look at a live demo of how Pinakastra Cloud looks like and what we are. And for that, I'll start with a quick introduction of Pinakastra Cloud itself. Just to give a quick introduction, so Pinakastra is an organization which is committed to make cloud computing infrastructure more accessible to enterprises, academia, and research organizations. So our forte is the Pinakastra Cloud platform, which is based on open cloud technologies, and we do understand the hardware side of it also. So we are also good at designing and implementing and deploying hyperconverged infrastructures. So what you look at the slide is on the left side, which is AI stack. So it's a complete AI cloud stack, which comprises of compute, network, object storage, block storage, and so on and so forth. What you see, and few solutions as database as a service, container as a service, which part of it which would be included in this demo today. On the right side, what you see is the edge cloud, or you can call it as a distributed cloud infrastructure, wherein for specific use cases like what you see, like transportation, manufacturing, and where latency, bandwidth, security, connectivity matters, right? In that scenario, we also help enterprises to deploy edge cloud. You can see this is our edge cloud native platform, which is depicted in this diagram. So having said that, I'll quickly move to the platform demo, which is actual agenda for today. So let's start with the self-service dashboard, wherein I'll show many of these components which are listed out here in this slide, right? I'm not planned for a demo for an edge cloud at the moment. It will be only the cloud part, which is infrastructure as a service, and the solutions built on it. Okay, so this is the self-service dashboard which you can see. Uh, One second, somebody has joined. Okay, so this is the self-service dashboard on which we help our customers to do provisioning on their own. And this is, as name suggests, it's a self-service dashboard wherein they can log in as a tenant, since this is a cloud platform, which is also a multi-tenant platform. Any customer who wishes to provision cloud resources can log in and he can do his self provisioning. So that is what is part of this demo. Going ahead, let me log into this self service dashboard. And what you see the moment you log in is the landing page of this self service dashboard, wherein you have a lot of information shown where here there is a part where it shows what are the instances running. The instances in the sense the virtual machines, the kind of storage information, the networks, which is software defined networks, and the networking software defined networking components. So for example, router. So all these, if you could just click on all these things, it will take you to the relevant sections. Down here what you see is the cloud resources quota. So since it's a multi-tenant architecture, each tenant will be assigned a particular quota, which he or she cannot cross unless the quota is uh, changed. So what you see is there is a quota for this particular user, for compute, for storage, for the network, and the containers, also the database. Because you can see this first three parts comprises of the infrastructure as a service, and below are few solutions which is part of this platform, which is container as a service. Then you can see some database as a service also, which subsequently I'll be demoing. So this is the landing page, which gives comprehensive information. Let me click on one of these, which will show you what are the instances running. Again, when I say instances, I am just talking about virtual machines here. So going back to the home screen, the idea is to go by the menus. You can see this cloud platform has a lot of options, a lot of cloud resources creation possibilities, and in each of these sections I'll be going one by one and showcasing the platform altogether. So as planned, let me expand this menu, which is on the left pane, which is compute menu, where you can uh, create virtual machines of different flavors or configurations. So I'll be showing how to create a first virtual machine when on a Pinakastra Cloud. For the sake of time, we have created many VMs already, uh, uh, which we will be showing subsequently. But for a start, we will create a basic virtual machine, which also I'll be using it later. So I am just creating a basic Ubuntu virtual machine of this configuration, which will give the virtual machine one virtual vCPU and 2 GB RAM. So I just need to select the operating system which I want. There are so many operating system images here, you can see. These are all custom images which was created by our team, but I'm just going to create a basic Ubuntu 2204 machine here. So I've selected the operating system here. So there are other options also. If we have instance snapshot created, we can select that snapshot and recreate. I'll explain what is an instance snapshot next, because that is the next menu item. So I'm just selecting the basic Ubuntu 2204 LTS operating system. Uh, Also, you have many other options also here. There are many images under Fedora. You can see we have Windows 7, 10 and XP. Under Debian you have Debian 9, 10. So there are two images under Core OS. We have Arch Linux, so free BSD, Net BSD, and few other operating systems which can be selected. But for now I'll be selecting Ubuntu 22, and our storage backend is actually Ceph storage, which is a distributed storage technology. So here we have the option of block devices, and by default I'm going to give it a 20 GB root volume, and proceeding to the next screen. So the next screen, what we have to do is we have to select the networks on which this VM is going to be created. So here we have a couple of options. You can see few tabs. One is the current project networks, because it's a multi-tenant network. You can see this is one network uh, which is already in place, but I'll be selecting this internal network for creating this VM. And then there is something called security group, in which we have all the security rules defined. So I'll select the default security group for the moment and proceed to the next screen. Here is what I will be giving my VM name, and I'll have a option to select the SSH key. So here I'm selecting a key. If you want to create a new key pair, yes, you can create using this option, but I'm not going to create a new one. I'll be reusing the existing one here. And there are a few advanced options here. For now, there is a user data section wherein you can put in few commands, and these commands will be running will be executed by Cloud Init as the Cloud VM provisioning happens. So I'm just skipping that part and going to the next screen, and this is the screen where you get the whole summary of what we are going to provision right now. So here the final step is to just confirm, and there it goes. So we have created a virtual machine which is in the build status at the moment. It may take like less than a minute to complete. Meanwhile, I'll just show few other VMs which are already running. So you can see there is a VM called AI Workbench. You can invoke the console from here like this, so which is the VNC console. You can see the UI of this Ubuntu machine. Again, in this image there are few extra things like Anaconda and all installed, so it comes readily available. The operating systems with the UI can be accessed through another method, which is remote desktop protocol RDP, which can be done in the same way. I've already included this particular machine, so I just need to double click and just say connect, and through RDP remote desktop, again I get the desktop in a full screen version. So any virtual machine with GUI can be accessed through RDP, and the machine which I just created now, I think it is active now. So it has a fixed IP, which is an internal IP. For L3 routing, what we do is there is a concept called floating IP, and if we want to have a separate access for this SSH access to this machine, one extra thing what we need to do is associate a floating IP. So that is what I am doing right now. So there is a pool of floating IPs which is like listed out here. I am just selecting one of them and assigning to this VM. So you can see this VM has got the new floating IP. So the very first thing what we have to check is we'll try to do a ping test and see if we are able to reach this VM. Yes, we are able to reach this VM. So now how do we SSH? SSH -I, and we have an SSH key used. So I have that SSH key with me. Since it was a Ubuntu machine, by default the username is Ubuntu, and I'm just giving the IP here. yes, I have successfully done SSH connection. So I just change as root user and clear my screen and run apt update, and you can see the update is happening, right? Okay, let it go like this. Meanwhile, we will move back to our self-service dashboard, and we'll go to the next option. So you can see a lot of machines are running. You can even see a Windows machine running here, right? So we can even do an OVNC console for a Windows 10 machine, and you can see it's the same way. It's a VNC console, and the same virtual machine can be accessed through an RDP also. So this is that virtual machine with Windows 10. So a double click will automatically connect, because I've already provided the credentials for this virtual machine, and you can see uh, we have successfully connected to a Windows 10 machine. So again, this is a ready image. You can see a few components already installed in this ready image, because this image was created for a university use case. So you can see this Turbo C, which is already available, and there are few dev tools, installers and all available, and this was based on their requirement. This is a custom Windows 10 image which has readily available tools for ready installation. So going back, let me explain the instant snapshots. Suppose we this is something like taking instant snapshots of VMs. So these VMs, when we work on these VMs, when we are doing a long tasks like installation tasks and all, then anything, if we think we don't want to screw up things, it is always better to take instant snapshots at various intervals, so that we can always restore these snapshots. So that is this option, and these are the configurations. We call it flavors, we can call it configurations which are available. We can create more flavors like this as per our requirements for the VMs. The next thing is the images. So these are few ready images which we have uploaded to this particular platform, and you can see lot of ready images are there based with base Ubuntu, and there are few other images in public. You can see there is a Kali Linux image which is a live image. um, so all these are based on customer requirements. These are custom images. So this is an Ubuntu 22 machine with Android Studio, and this is Windows 10, and there are Fedora neurosciences live image. So many images. Next is the keypads. As I said, there are two ways to access these virtual machines. One is the password method, uh, that is, while creating the VM we have to give the password. That is one method. The other one being SSH keys. So the demo which I showed just now, the SSH demo, uh, was through SSH key. So next is the storage part. So as, as we talk about infrastructure as a service, these are the main three building blocks of any cloud infrastructure. The first being compute, the compute engine, which is based on KVM hypervisor, and the second is the storage, and we should be able to uh, provision storage on demand and attach to the instances as we uh, require. So here you can see there are different block volumes created, and each of these block volumes are attached to a particular VM. In this case, if you remember, this is the VM which we just created in the beginning, and I show you this 20 GB in the VM itself. Here you can see this is the 20 GB attached to this VM. I'll just clear the screen. This is this 20 GB attached to this VM. So how do we create a new VM, I mean new volume, and attach to it? That is what I'm going to display now. You can see there is only one disk at the moment. So what I'll do is I'll create a 100 GB volume, say 100 GB volume, and just giving demo volume a name and then confirming it. So immediately the volume is available, but it is not attached to any VM. So it's quite easy. So here there is an option to attach to a particular VM. So all the VMs in this tenant is listed out. So I just wanted to attach it to a demo VM which was just created. So I'm just selecting that VM and saying attach. So within few seconds it got attached as a second device. So here you can see the same command I'm running, this 100 GB disk volume got attached. Same way we can also detach it anytime, and also attach it to another VM if required. So I'm detaching the same 100 GB volume here. Yeah, within few seconds it is vanished. So again back with only one disk here. So this is how it makes a seamless provisioning of resources. So these are other options for volume backups and volume snapshots. And the next is the network option, wherein you can create multiple tenant networks, and each tenant will have their own tenant network which is isolated. So I'll just show you the topologies for quick understanding. So here this is the external network, which is provider network, uh, and there are a few routers here, which is virtual router, which connects the internal network on which these VMs are running. And for external connectivity, what we do is there is L3 routing which happens, and through these virtual routers, actually these virtual machines can be accessed. And for accessing, as I said before, we need to assign something called floating IP, which is nothing but the L3 subnet. Only then we will be able to connect to all these VMs. So next is VPN. So we can create VPNs also for connectivity. So in that case, we don't need the floating IPs to access these um, virtual machines. So if we have a VPN setup done, then probably we can connect to the VPN and virtually get into the internal network and access all the VMs. So at the moment this is not set up. So moving forward, so security groups, as I said, this is a group wherein you can see lot of security rules can be added as per the requirement, and we can have multiple security groups based on the usage. Like for example, you can create a separate security group for web tier or database tier, some application tier, as you wish, and you can just restrict with certain rules. You can certain ports which is required. You need not keep all the ports open, all 65,000 ports open. So the next part is the orchestration part, I'll quickly ask my colleague Anas to take over for showing this demo of how the stacks orchestration menu works. So orchestration is nothing but we always talk about complex infrastructures which we create over a period of time, and there is a need for quick destruction of those infrastructures and recreation at times. So in that case, there is a concept called infrastructure as a service, wherein you can just code your infrastructure and you can quickly destroy or create the complete technology stack as and when you require. So that is what Anas would be showcasing right now. Anas, over to you.
Hi everyone, this is Anas, uh, cloud engineer in Pinakastra. Thank you Ajit for giving the opportunity to talk about orchestration, uh, because orchestration is one of my favorite application in OpenStack. See, if you have heard about the Terraform, um, it's quite similar to the Terraform, but Heat is specially designed for OpenStack. See, let me.
Anas, do you want to share the screen?
Yeah. Let me share my screen. Is it visible?
Yes.
Okay. See, as Ajit mentioned, instances are here, and he mentioned about the topology. See, this topology we can see here: external network, internal network, routers, and a bunch of instances. See, can you believe that these all resources can be built using only one page of code? Yeah, that's what Heat doing. Um, um, yeah, here. Uh, See, you can see that one of file 3-tier YAML file. See, this is a file in YAML file, and I have written some codes. Um, this can You can see that 20 to 25 lines of codes only there. So what I'm going to do is that from this YAML code, I'm going to create a bunch of resources. Uh, See, let me explain the YAML code. Heat template version is mentioned and resource. See, I'm going to create a 3-tier architecture that contains 3 instances. One is for presentation tier, and one is application tier, and one is database tier. See, from this code, what I'm going to do to create 3 servers, virtual machines within a fraction of seconds. See, let me do that. See, by executing this code, let's see what will happen. Now you can see that one stack is in creating progress. This is the stack what I just now created. You can see 3-tier architecture, and it's in progress. After that, now you can see that 3 instances are also in build stage. See, these instances are created from my YAML code. See, everything is explained: presentation tier, and application, and database. See, that is here creating application server, database server, and presentation server. See, why orchestration is important is that it is automating the deployment. Um, it's making our task is very easy. In order to get a public access, let me connect to the floating IP. So this presentation server is connected with this floating IP. What I'm going to do, let me open the IP in a browser. It's still working, it's still creating the machine. So why this is important is that for we can use this for disaster recovery, because only one page of code, that if we keep that code, we can create the resources at any time, at any infrastructure, and it's reliable, means for a uniform set of resources, by executing the file we can create a uniform set of resources. uh, the chances of human errors are reduced, and it's very efficient, and we can implement very quickly. See, so you can see that a machine is created, and Apache is installed.
Can you show the section where you are installing the Apache in the YAML file?
Sorry.
Can you show the section in the YAML file where Apache is getting installed and this?
Okay. See, let me explain the codes once again. See, resources in YAML file, there is an important part is resources. Under these resources, we are mentioning all the resources that we are going to create. Maybe example storage, volumes, and maybe network, and instances, resources, virtual machines, and all the resources which provide by the OpenStack we can create simply, easily using the YAML file. See, in presentation tier that now just we launched, its type is a server, properties, what we do, the name of the server, and the key that we are going to use for accessing, the Pinaka demo key, and the image, and the small, and the flavor. And see, in user data we explain everything, like into install Apache, and to load a file from zip, means and we can do whatever what we need. For example, creating Docker, and to deploy any Docker container, whatever we can do. See, I'm just simply executed the stack. You can see this stack is completed. So let's see the instances. 3 instances are also created, and if we open the floating IP, see, a 3-tier website is open successfully. See, this is very simple, that to launch a 3-tier architecture only using a page of YAML code. So how this is making simplify all the procedures of our manual works with the help of heat orchestration.
Sure, thanks, Anas. In the interest of time,
Thank you.
we'll move. Thanks for sharing this information. Let me continue sharing with the screen, and I'll proceed with. So basically, what Anas was showcasing is the infrastructure as a code. The native uh, method is called heat service, which is used, and it's a human readable YAML file. Anybody can write a YAML file and save it as a file, infrastructure as code, and anytime on demand we can recreate as and when we need, and it hardly takes few minutes to create. This is particularly useful when you have a very complex architecture, which involves many virtual machines and connectivity and all those things. So we can, once for all, you code it and keep it, and then you can reuse it anytime. So that was the idea of orchestration module. So moving back to the database as a service. So this is the option for database as a service. For example, there are options to create multiple databases as a service, like Postgres, MariaDB, MySQL, and many things. For this demo, I already have a MariaDB instance running, and you can see the details of this MariaDB here. So the host and MariaDB default port will be 3306. Everybody knows all those things. So you can see there are a couple of default users which was created, and databases. Uh, this was part of creation itself. I'll just show you that creation thing. So let me create. I'll say demo MySQL.
It's great.
Sorry, let me go to the creating the new demos. So I'll say demo MySQL and just get 10 GB. I'll select, see currently I have only MariaDB and PostgreSQL. So I'll use the MariaDB, and data store version is 10.6. So here you can select any of these flavors which is available. So let me select this.
Hi Ajit, can you make sure the screen is visible?
Uh, so screen share is not working. You're not able to see the screen. Can you see the screen now?
Your speaker is off. Speaker is also.
Can you see now?
Yeah, it's visible, sir.
Yeah. Okay. I don't know where I missed. So this is the menu I was explaining. This is database as a service, and I already have a database MariaDB created here. So this is database as a service. So you can I'll just show you quickly how to create a database as new database. So I'll say MySQL demo and assign 10 GB, and you have multiple data store type. For now I'm selecting MariaDB, and it's 10.6 version. I'll just select one of these configurations and go to the next page. Here again I have to select the internal network on which these database instance is created. Now here we can create any virtual machine, database. I'll say IndiaDB. I'll create an admin user, and I have to provide a password. So going to the next screen. Yes, let me confirm this, and it is in the building stage. So in the interest of time, let me use the existing MariaDB, and let me show you how it is internally connected from a existing virtual machine. So this is the virtual machine I just created initially. So let's see how to access, because this is the internal network. We should be able to ping this database instance also. Or let me use another VM. So I'm using another VM wherein let me try Okay. So I already have installed MySQL client in this machine. Sorry. Yes, I've already installed. So only thing I have to do is connect. This is the host name and username is admin. I'll just give. Yes, now you can see I just connected to the MySQL database. So you can see there is a Pinakastra DB already available. So let me show you how to add a new database to this. So this demo MySQL is a new database I just added. So we may have to give a okay, let me go ahead and create one table. Sorry, I'll use there is already a table created which I created earlier. So I'll just change the table name as employee table 1. So now you can see both tables are there. So this is how you can connect internally to this is equivalent to the RDS in AWS. So from any VMs, generally we don't expose the database, so there is no concept of assigning a floating IP. So only ways to access this database instances through virtual machines, because it is never exposed like normal VMs. So that is the database menu. This is database as a service. The next thing is the container as a service. So here if you look at container as a service, I've already created a cluster template. You can see this is a Kubernetes cluster template which I've already created, and which says it can create one master node and multiple worker nodes. And based on this template, I've already created a Kubernetes cluster like this with this cluster size, where there is one master node and 3 worker nodes, and the API can be accessed through this. So let me connect and show you. I'm just exiting this. So I am just connected to the master node. You can see it is 103. IP is 103. These are these Kubernetes cluster nodes. So this is the master node to which I am connected now, and we will see how these worker nodes are attached to this master node, and we'll see how to make a deployment and do certain things. So just going here, so switching as root user. So So Q, it's a Kubernetes orchestration engine which we have selected. Actually, we have multiple options like Docker Swarm and Mesos and Kubernetes. In this demo, I have selected Kubernetes. So you can see these are the nodes connected. This is the master node, and these are three worker nodes which you can see. Let me see if we have any pods running. There is no pods yet. Let me check if we have any deployments yet. There is no deployments found. So I'm just going to create a quick deployment and I'm using the Nginx ready image. So the project is created. Let me see if we have the deployments. Yes, now that we have the deployments. Let's see if we get the pods. Yes, we have one pod running. We can always scale the number of replicas easily. Scale up or scale down. At the moment we have only one replica. So let me try to create 4 replicas. So it says now it is scaled. So let's see. Yeah, now from one replica it has scaled up to 4 replicas. Same, we can scale again if you want. From 4 we can make it 10. Let's see. Yes, now all the replicas are created, and we are very sure these replicas are created across all 3 worker nodes which is running. So this is the basic infrastructure. Kubernetes infrastructure, one master node and 3 worker nodes, and that is what we saw here. One master node and 3 worker nodes. Now let's see if it is scaled up. Yes, I think only 2 more. Yeah, all 10 replicas are running. Let me scale down again back to, say, I'll scale down to 2 replicas. You will see the replicas getting terminated, and finally it's only 2 replicas running. So this is how the scale up and scale up is done. So this is one way to create a deployments. Let me just quickly delete this deployment and show you the other way of creating a deployment, like how Anas did showcase the easy way using a YAML file. Yeah, now there is no deployments. Yeah, so I already have a YAML file here for Nginx. I'll just show you what is there in the Nginx file. So here we have a load balancer also created, and there is an Nginx project deployment using and by default 4 replicas. I'll just change it to, say, 7 replicas, and let's see how quickly this gets created. So all we need to do is apply this use this YAML file, and it automatically creates the deployment and also adds the services. So get pods. You can see 7 replicas are running as we mentioned in this YAML file. Let's see the deployment. And let's see what are the services. Yeah, this is a, so at the moment we don't have the this particular cluster template. We have not exposed it with an external IP. So what I'll show how to in case it is exposed, how to access the dashboard, Kubernetes dashboard for orchestration. That is what I'll show you. So this is how we retrieve the token for the dashboard, and since we don't have the external IP assigned at the moment, we cannot show the Kubernetes dashboard, and this is the token which should be used for accessing the dashboard. So like this we can use this Kubernetes as a service for any tenant can create their own Kubernetes cluster on demand like this, and deploy all the containers whatever they like, and they can scale it up and scale it down on demand and use this feature. So this is what we had for this demo, showcasing the complete options. We all also have few other additional optional services also, but these are the basic services which generally anybody would require, especially the database as a service and the container as a service is very much in demand. Everybody requires it because the application development monolithic architecture is